Okay, so let us start characteristics of sound. Characteristics of sound. So first thing is about what is loudness. 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 So what is loudness? Loudness is related with intensity. Okay. Loudness is it is related to intensity. Intensity. Okay, and intensity, you know what is intensity? We have previously discussed also what is intensity. Intensity is nothing but energy per second per unit area, or it is power by area, right? So intensity is also related, like intensity is related as power by area. Okay, now suppose if there is a source of sound, let us say that this is a source of sound wave, and it is producing some, uh, energy or intensity. So how do you calculate? It will have a particular power. Let us say we are taking it's a point source, and it has some power is equal to P, and I want to find out intensity at this point. Let us say at this point I want to calculate intensity. So how do we calculate intensity at this point? Okay, we want to calculate intensity. So to calculate intensity, what we need to do is we need to know that this it is a source of power or source of energy. It is emitting energy per second, and energy per second is constant, let us say, because any source you take, it will have a particular power, right? Any source of wave, for example light source, if you take bulb, electric bulb, it will have a particular power, let us say 1000 watt. 1000 watt means it will emit 1000 joule per second. Okay, that will be constant. Generally power is constant. So this source also has a constant power, and you want to calculate intensity at this point. So what you need to do is you need to draw a sphere. You need to draw a sphere like this around it. And considering that this source is like the center of this sphere, you need to draw that. And whatever energy it is emitting, let us say it is emitting energy in all direction. So this energy which is being emitted per second, which is power, same energy is being received on this whole surface per second, right? So the power emitted and the power received on the entire area is same, and you want to find intensity here. So to find intensity here, you have to consider this entire area. Okay, so intensity at this point, let us say that this point is A. So intensity at point A, that is I, intensity will be calculated as power divided by area. Power is P, and this area, let us say that this distance is small r. So the area of this sphere you have to use 4 pi r square. So you can say that intensity is inversely proportional to square of the distance, right? Okay, so intensity received from a source at a particular point is inversely proportional to the square of the distance of the observer from the source. There is an observer here whose distance is r, so it is proportional to r square, inversely proportional to r square. And previously we know already, if you remember, you already know that intensity of wave is proportional to what? It is proportional to amplitude square, right? You know that amplitude is A here. A is amplitude. Intensity is proportional to amplitude square, and also you know that intensity is proportional to frequency square also, f square. F here is frequency. So this relationship we should know, right? Intensity is proportional to amplitude square, intensity is proportional to frequency square, and intensity is also inversely proportional to the square of distance. Okay, right. Now what about loudness? This concept is valid only for a point source. If there are different sources, then intensity may change according to the source, and this concept depends on wavefront. So the concept of wavefront you will be studying in light, particularly you will study that in case of light. But here you can note here that what is wavefront. Wavefront is nothing but all such points which are, same distance from the source. When you join them, it will become a wavefront. So if you consider the source at the center and join all the points which are equal distance from the source, that means it will be a sphere only, right? So that is why it is a sphere. This is called a spherical wavefront. Okay, this is called spherical wavefront. And this concept of intensity is only true for spherical wavefront. Okay, this is only correct for spherical wavefront. Okay, but what will happen if this wavefront is not spherical? If wavefront has different shape, so you can choose some different cases also. Suppose if I say that the source is not a point source, it is let us say it is a line source. Okay, line source. Then what will happen? Here also we can see that for line source, for line source we have cylindrical wavefront. The wavefront is like cylindrical. Okay, like this. And line source means the source is like a line. Okay, so the source is like a line. So now if you want any, let us say this distance is r and this point is a, you want intensity at this point. So now the area which you need to consider, that area will be the curved surface area of this cylinder. Okay, so everything will remain same. Let us say the height or this length is L, radius is r. So the intensity formula is power by area, but area here you have to take as 2 pi r into height. So 2 pi r into height, which is L. So here you can say that intensity is inversely proportional to r. Okay, so this concept of intensity is valid for line source or cylindrical wavefront. Okay, cylindrical wavefront. But the relationship of intensity proportional to amplitude square or frequency square, that will not change whether this source is a line source or point source. That doesn't change. So line source or point source can change the shape of the wavefront, and because shape of the wavefront changes, so this relationship with distance can only change. Okay, that is we have to know. What will happen if this source is very far away from the observer? That means it will become like a plane wavefront. Okay, plane wavefront. So let us consider that. So source for plane wavefront or for source very far from observer or listener. So in that case, what will happen? In that case, suppose this is source, but this is very far away. Okay, distance is almost infinity, you can say. Distance is infinity. So for such distance, for such objects, you can consider source like a point only. It is a point source only. But distance is very far away. So even if you try to draw a sphere with this as the center, so radius of curvature infinity means this is like a flat, right? This is almost like a flat surface, almost like a flat surface. So if the surface is like a flat or a plane surface, then what will happen? Will it depend or not? Hmm? Will it depend or not? So here it will not depend because distance is very far away. So it does not depend on radius. You can say that the intensity is independent of radius. Intensity is not at all depend on radius. Radius power 0 you can say. Okay. It doesn't depend on radius. Intensity is independent. Independent of distance. Okay, so we should remember these three type of sources. If it is possible, in the question they can change the type of source. They may say it is a source at infinity, or a cylindrical source, cylindrical wavefront, which is line source, or point source for a spherical wavefront. They can give anything in the question, and according to that the calculation of intensity will be different. But we are saying here loudness. How is loudness related to intensity? Intensity is a normal technical term, but loudness is not a so much technical term. Why? Because loudness is something which we are using in daily life. Loud music, loud noise. Okay. So how do we describe loudness then? So loudness is related to intensity, as I said. So loudness is measured in decibel. This is called decibel. And loudness, let us represent loudness as beta. So beta is related as tan log base 10 I by I naught. Here this I naught is called threshold intensity, and this value is 10 to the power minus 12 watt per meter square. Watt per meter square is the unit of SI unit of intensity. Okay, right? So beta we calculate, means this is the formula which we have to use. The unit of beta is nothing but loudness. So beta is calculated, beta is loudness. Okay, now sometimes you can say that I can use a value in terms of intensity. So you know what is log, right? Log term, you know, log means if I try to bring 10 this side, so beta by 10 will become log base 10 I by I naught. Then I can write it like this. So log base means 10 to the power this, 10 to the power beta by 10 will become equal to I by I naught. I by I naught. Then I naught will multiply this set. So I can be written as I naught into log, not log, log is over now, this is exponent. Log, and this log is not there, 10 to the power beta by 10. Okay. So this is how beta and I is related. If you want to calculate beta, then you can use this. If you want to calculate I, then you can use this. Okay, according to that, you can use that. Clear? Are you clear about that? Okay. Now here, let us understand what will happen if I choose some value of loudness. How is loudness related with intensity? We know this, but let us take some quantitative values. Some values you can see, and we can try to see the relationship. Suppose if I take, for example, if I take two values of loudness, suppose I take beta, first case beta 1, let us say it is 10 decibel, 10 decibel. Second case I take beta is equal to 20 decibel. Two values we have taken, and we want to find out how the intensities are different. Suppose there is a music box from which sound is coming, and this loudness is 10 decibel. Another music box, loudness is 20 decibel. So how much is the intensity ratios, or how many times is intensity? So you can see here, if I have taken double loudness is double, so how many times intensities are there? First you calculate for this one. I1 will become I naught into 10 to the power beta value is 10 here, so 10 by 10 will become 1, right? Here beta intensity 2, what will be intensity 2? Calculate I2 second intensity, same way 10 I naught into 10 to the power 20 by 10 become 2. So you can clearly see that this I2 is equal to how many times? You can take ratios. So how much? 10 times, correct? 10 times I1, right? 10 times I1 it is. Ratio you can see that, because this is 10 I0, this is 100 I0. If you take ratio, it will become 10 times. So if the decibel or loudness become double, intensity become 10 times. Are you clear about this? Yes? Right. So this fact we should know. Sometimes questions comes that intensity become double or triple or 4 times or 5 times, like that. How many times the intensity changes? So this is how we will calculate this. Okay, done. This is over. Then let us go next. Next characteristics is pitch. Pitch. Pitch, it is related to frequency. It is related to frequency. Pitch is related to frequency, and frequency we understand what it is. Suppose for example there is a wave like this, okay, between the same time you are seeing, and between the same interval, if I represent the wave like this, that means high frequency. Number of waves are very high within the same time. Here number of waves are very less. So this is like low frequency or low pitch, and this is high pitch. Okay, so low frequency, low pitch, what it means, and when it is low, when sound has low pitch and when sound has high pitch. So the voice or the sound produced by men are low pitch. Sound of men are low pitch, and high pitch sound of women, as well as sound of children. They are high pitch. So children and females have high pitch, okay, but men have low pitch. Low pitch means low frequency. Okay, that's all we have to know about this pitch. Okay. Then next thing is about quality or timbre. Third thing is about timbre or quality of sound. How do we measure this? Okay, so quality or timbre is measured, it is related to the smoothness of the signal, the sound signal. Suppose if you take a wave like this way, and if you take another wave which is like this way, now both are sound signal, sound wave, but this first one is a smooth graph, so this is known as high quality high timber or high quality, and this is known as low timber or low quality. So quality is low here because it's a rough signal, is rough, it is not regular, it's a irregular graph. This is quite regular graph. That's the difference between, you know, high timber or high quality, low quality. Are you clear about this? Yes. Okay, done. So we are done. Now let us solve questions. Okay, so now whatever time is there, we are solving questions on this chapter. This is a high weightage chapter. Waves has lot of topics. We have seen that we have covered almost everything, and whatever is there you will learn through solving problems. Okay, so let us start problems. Various type of questions we can see that. So we can start from the back topics, right? Back, that means last topic which we have covered is, right, beats and other things and this topic. So let us see questions on that. So sound, basically sound was the this topic. Let us start questions on that. I will give some questions and you try to answer them. Okay. Question number 1. When a sound wave is reflecting from a wall, the phase difference between reflected and incident pressure wave is. So, suppose that this is a wall and here this is a sound wave. Sound wave. It will go and it will reflect. After reflected, it will be coming like this. This is reflected. Okay, this is incident. Question is the phase difference between reflected and incident pressure wave. The phase difference between incident and reflected pressure wave is option 1 0, option 2 pi, option 3 pi by 2, option 4 pi by 4. Tell me your answer. What is the correct answer? How much? Pi. But the answer is not pi. What is the reason behind it? Okay, now think about it first. First, you have to think this term called pressure wave here. This is not the displacement wave. Remember, this is pressure wave. Sound has pressure wave. Sound we can represent as pressure wave, displacement wave, density wave. We can write different function, and here they have asked to take sound as a pressure wave. We can take displacement wave also, but here they are saying to take this as pressure wave. What does that mean? So generally when we take the wall, we take it as a rigid point. Rigid point means what? Rigid point means the displacement will not happen. That means there is a node there. Correct? Yes? Right? So when you take this as node, this node we are considering as node for displacement wave. This node is for displacement wave. For displacement wave, we are taking this as node. But what about when we take as a pressure wave? For pressure wave node, this displacement node will be pressure node or pressure antinode? Tell me. Yes. See, let me write the equation. If you remember, I think you might have remembered displacement when we have written, it was A sine omega t minus kx, let us say. But when we write the pressure delta P, this is delta P max, and this sign becomes cos. You remember this? Yes. Okay, so wherever displacement is like 0, that means sine is 0. Sine is 0 means cos will be maximum there. Okay, that means let us take the angle 0. So sine is 0, so displacement has got no. But when angle is 0, cos is maximum, so that is antinode. So wherever displacement has got node, their pressure is antinode. Okay, and wherever displacement has got antinode, their pressure has got node. So they are out of phase by 180 90 degree, you know that, right? Okay, so this, when you are saying that this is node, which node it is displacement node, because here displacement cannot happen. So this point which we are talking about, this is displacement node. This is displacement node. Now, if this point is displacement node, this must be pressure antinode. The same point is nothing but it is pressure antinode. Pressure antinode. Okay. So this point, which is displacement node, is pressure antinode basically. And if this is pressure antinode, so pressure will not change. Na? Antinode means it's like a free, right? Free end. Antinode means it's a free end. So pressure wave will not change there. Okay, so when you consider reflection of pressure wave has got antinode that point. And when reflection happens from antinode, the antinode is like a free end. So reflected wave, when it is coming, inversion does not take place at antinode. That's why there is no phase change. Phase change will be 0, you can see that. Are you clear about this? Yes? Okay, so now the thing is that this may not be explicitly mentioned in the book. So when you solve the question, then only you understand, oh, this pressure node antinode is different than displacement node antinode, right? That is what it is. That is why important to solve questions, that we get so many ideas. Okay, let us move next, question number 2. Under similar condition of temperature and pressure, in which of the following gases velocity of sound will be largest? They are saying that under similar temperature and pressure, that means same condition of temperature and pressure is there, velocity of sound is largest. Velocity of sound is largest in, so which gas is largest? First they have given hydrogen, second it is given nitrogen, third it is given helium, and fourth it is given oxygen. Okay, try this. hydrogen. Hydrogen. Okay, let me check the answer for this first. Question number 2. Hydrogen, correct. So velocity depends on root under gamma RT by M, or you may also say root under gamma pressure by intensity. Any of this you can use. So let us say that we are using this equation. So gamma and this molecular mass, both you need to see them. Gamma by molecular mass. Okay, so gamma you need to consider here, the gases are monatomic and diatomic also. Monatomic is helium, others are diatomic. So gamma value is what for monoatomic and gamma is for diatomic. How much it is? It is 1 plus 2 by F, right? So it is 5 by 3, 1 plus 2 by 3 and 1 plus 2 by 5 if I take, so 7 by 5, right? So which one has more value? You can check also. First monoatomic and this both you check. This is how much? 5 by 3 means 1.67, correct? Right. And what about 7 by 5? 1.4, correct? So monoatomic is more. What about molecular mass? Molecular mass also you need to check. So you may check molecular mass, but molecular mass is very small for hydrogen as compared to other, right? So basically you need to check the ratio of gamma and molecular mass, and when you are calculating for hydrogen, it is coming highest value. That is why it is largest, correct? Right? Right, we can do that calculation, but no need, because molecular mass of other gases are heavier, larger. Okay, so let us move next question. Question number 3. The monatomic ideal gases 1 and 2 of molecular masses M1 and M2 are enclosed in separate containers kept at same temperature. So two containers are there. Two containers. Temperatures are same. T, they have same temperature. Molecular masses are M1 and M2. M1 and M2 are molecular mass. Okay. Separate containers kept at same temperature. The ratio of speed of sound in gas 1 to that of, so suppose the sound speed is V1 here, sound speed is V2. So you have to find out V1 by V2. Two different containers are there, but they have same temperature and molecular masses are M1, M2, right? So speed of sound ratios we have to calculate, and the options given are, let us take the options. It is root under M1 by M2, root under M2 by M1, root under, not root under, it is M1 by M2, it is M2 by M1. Tell me which is correct. Second option. Okay, let us check that. So velocity of sound formula is root under gamma RT by M, molecular mass. Okay, so temperature is same. What about gamma? Gamma is monoatomic. Both are monoatomic. Okay, both the gases are monoatomic. Monoatomic. So that means gamma is also same. So speed is inversely proportional to root of molecular mass. So V1 is proportional to root of M1, V2 is proportional to root of M2. So when you take the ratios, right, so that will come root M2 by M1. Correct, that is the right answer. Okay, let us go to the next question. Question number 4. A 10-meter long rod of density and Young's modulus is clamped at one end. So this is a rod. This rod is clamped here, and length of the rod is given. Let us see. Length of the rod is 10 meter. Young's modulus is 10 to the power 11. 10 to the power 11 Pascal. And they have given density of the rod 10 into 10 to the power 4 kg per meter cube. Okay. It is hammered at one end. The longitudinal pulse goes to right end and gets reflected and again returns to the left end. How much time the pulse takes to return back to left end? So suppose you are producing a longitudinal wave here. So there is a hammer. This is a hammer. And using a hammer, you are beating the other end. So when you are beating, a sound wave is produced. Sound is a longitudinal wave. Okay. So here in this rod, a longitudinal wave, that is sound wave, is produced from the left end and it is traveling to the right end. It will get reflected here and it will again come back. So the wave which is produced here, this wave which is produced here, this wave is going, and then after hitting it, it will come back again, right? The wave will travel back again. So how much time it will take going from left to right and then again right to left? Total time taken is how much? That is the question. Time taken for the wave to return is, options are given: 0.01 second, 0.02 second, third is 0.13 second, fourth is 1.2 second. Okay, try this question. So to calculate this time, you need the speed. How are you calculating speed? Young's modulus by density, yes. Young's modulus by density. Sound wave in solids, okay. Sound waves, speed of sound in solid. Root under Young's modulus by density. In liquid, the same Young's modulus become bulk modulus. Bulk modulus is gamma times pressure. That's all. So here Young's modulus in solid. So use this. Once you calculate the speed, then time is equal to distance by speed, and distance you have to take this and this. That means 10 meter, 10 meter, 20 meter is distance you have to take, right? So tell me, what is the answer? Quick, you can solve fast. You have to increase your speed. And without taking help from anything, you have to solve, because then only your practice will be there, right? Hmm. Numbers are not difficult, na? This and this is there. Yes, that is right answer. Correct. Because speed becomes root under this Young's modulus and this. This is how much it is, 10 to the power 5. So when you divide 10 to the power 11 by 10 to the power 5, this is 10 to the power 6, right? 10 to the power 6 means it is 1000. So that's also time is equal to distance by speed. 10 meter, 10 meter, 20 meter, 20 divided by speed, 1000. That is what it is. Okay, let us move to the next question. Question number 5. The displacement versus position graph has been shown for a certain section of a medium. Select the appropriate pressure change versus position graph. So this graph is displacement versus position graph. Displacement is as, or if you want, you can write displacement as y. It doesn't matter. Generally, we are using the symbol y. So y versus x graph is given here, and the graph is given something like this. Not exactly like this, but like this type of graph is there. Okay. Now they are saying that select the appropriate pressure change. So you need to find out which graph shows pressure versus position graph. Which graph is correct? So their options are graph. Okay, first option I will draw. So pressure versus x graph is given as like this. Second graph, option B, pressure versus position graph is given like approximately. The graph may not be looking exactly, but it is like that. Okay, then another graph is also there, C and D. Okay, so now try to figure out which of these graph ABCD represent pressure versus X graph. Here displacement versus X graph is given. This graph is checking your concept. This type of questions are coming in need these days. Okay, try that. Okay, tell me, what did you think about it? Why did you choose second option? Hmm? Give your reason. What is the reason? You must have thought about it. Pressure is forced by area. No, you think in terms of sound wave. Basically, this chapter is a wave, so you think about the sound wave. In terms of sound wave, you think about like this is the waveform, right? This is like waveform. So in terms of waveform, you think this is like when you see these options, this is pressure versus x means that is the pressure function, and this is yx graph means this is the displacement function. So they have given displacement function and you need to figure out a pressure function, right? Like that you think about it. And remember, from the graph also we can figure out nodes and antinodes. Wherever the, like for example, displacement graph, if you are saying displacement graph, wherever the displacement is maximum, that is antinode. Wherever the displacement is minimum, that is node. Clear, right? So if you see this graph, from this graph you can say definitely that there is a maximum displacement, so there is one antinode, but this is displacement antinode, okay, and there are two minimum value. Minimum means it is node, so there are two nodes are there. There are two displacement node and there is one displacement antinode. So similarly, if you are drawing the graph of pressure wave, in pressure wave graph also you need to now think about how many pressure antinode and node can be there in the pressure graph. Yes. How many pressure nodes and how many pressure antinodes should be there in the graph, pressure graph? Yes, now you are correct. Because wherever displacement antinode is there, there is pressure node is there. And wherever displacement node is there, their pressure antinodes are there. So these two nodes will become antinode in this graph, and this antinode will become node. Now tell me which graph is possible. You are very close to the answer. You can just think about little bit. Fourth option. Why? Okay, tell me in the fourth option you have chosen, uh, how many nodes are there? Then you can choose that, right? These are two nodes and this is antinode. But we want these two node will convert into antinode. So you want two antinode and one node. This is not correct. You just try to make now. Make. Suppose if I make here, this is node, this is node, this is node, and this is antinode, this is antinode. Here there are two antinode, but there are three nodes. We cannot take that, right? Okay, this one you take. This is node, this is node, this is antinode. There are two nodes. We cannot take that. What about this? Node, 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 and we have antinode. So here also uh, two antinodes are there, but three nodes are coming here also. According to this graph, it should give one node and two antinodes, but three antinodes are given. How it is possible? Let me check whether this graph is given correct or not. Mm, Graph is given like the same manner, but they have given option 1 as the correct answer. What can be the reason for this? This antinode must convert into node, so this node is there. But what about these other two nodes? Hmm? Other two nodes, okay, suppose this if you consider as antinode you are taking, hmm? This side antinode, this side antinode. So here this is going like this way. So antinode means it must be in between. This side, I think they should have given the full graph. This is just only one peak they have given. One peak means two node will become two antinode. That means up to this much antinode it is okay, but they did not show further graph now. They have not shown further things in the graph. So if you go by number of antinode, so number of antinodes are 2 here and number of antinodes are also 2 here, right? Correct, right? So number of antinode if you go, because these two nodes will convert into two antinodes. So two antinodes are present in A and C. Now out of A and C, logically let us think about it. Out of A and C, which one to select? Can both A and C option are possible? Or do we need to think about more? Because see, if here, let us focus on this portion of the graph. If you focus on this portion of the graph, and here also this portion of the graph, if I focus. Now out of these two, which one can be correct? Hmm? Which one can be correct? Because I think here the slope, you see, the slope is like, positive slope. Here the slope is like negative slope. Negative slope. Which one we should consider? And why only A? Why only this? Suppose if we try to draw the graph of displacement and maybe then we can get some idea. Suppose if you draw yx graph, let us say that this is sine graph like this. And if I draw pressure x graph, Pressure is a cost function, right? Cost function will start from where? Cost function starts like this way, right? It starts, so wherever this is maximum, there will be minimum, and wherever this is minimum, that will be maximum. So pressure graph goes, cost graph goes like this. Cost, right? If I think of yx and px graph, suppose this graph which we have taken, it is like, I think it is like this segment. Maybe it is like this segment. Okay. So if you are considering this segment, then shall we only consider this segment? Yes, correct. Right or not? Because this is like a sinusoidal only. Let us take this is the first half of the sinusoidal, like this part. If you are taking sine graph like this, cos graph is like this. Okay, also see the formula in the pressure, is there minus also? Just check that. We have seen the formula for pressure, right? Is there any minus also in that? Check your notes. Yes, there is a minus symbol there. Did you see that? See, if you remember, we have written y is equal to a sine kx minus omega t. And while we are calculating the pressure wave function, we are studying the change in volume. So there is a small change in volume in this element, which is like delta x. This position is x. Okay, so how did we solve this? If you remember, bulk modulus we have defined, bulk modulus is minus delta p by pressure change, delta p by minus delta v by v, right? This is how we have written that. And what is delta v by v? Delta v by v we have written from here as change of volume. So change of volume is this volume. That means area into delta x, that is change, divided by original volume area into x. So from here, this delta x is like the displacement here. Delta x is like the displacement. Okay, delta x that has happened here, that is like displacement. Delta x is like the displacement, which is y, you can see. So the change of volume is area into displacement delta y. Delta y by this delta x. So we are considering this small element is like delta x we are taking, right? If you see the derivation, we have done this one by taking this only. So this ratio has become delta y by delta x, or dy by dx, right? Dy by dx, when you differentiate that, we get a sine differentiation become cos, and k also comes out, ka cos kx minus omega t. So here what we can write is delta p divided by minus delta v by v is delta y by dy by dx, which we write as ka cos kx minus omega t. Now we can write delta p as minus bka cos kx minus omega t. Do you remember this derivation? So there is a minus sign also, which we should not forget. Okay. So delta P is equal to minus, and this is there, maximum pressure, but cos of this is also there. Okay. So now I think when you see this graph, it will become very clear that this graph, when we have taken, this is y versus x graph, this is pressure versus x graph, but this is not cos, it is minus cos. Minus cos means you have to invert this graph. How will you invert this graph? This graph you have to invert like this way. Invert, because it is minus, so it should go like this way. Okay, this should be the graph for this part, and other part you can keep it like this, and this part now you remove because it has to be inverted. So down graph you remove it. Okay, now I think it is better. So what we have to consider this graph of pressure, because pressure has minus sign, it is not just cos, it is minus cos graph. So minus cos graph will be like this. So if this is the pressure graph, we must have this type of graph somewhere, and node will be this here. This anti-node converts into this node, around which the graph will be going first bottom and then top. Now you check the option. Now you check the option. So now you can see that this portion is matching. Yes, correct. Are you clear about this? This portion is now matching, but if you take this graph, this one, here it is this portion is not matching, because we have to get cos inverse graph. That is cos graph, and this is cos inverse graph. For this portion only, remember, we are comparing for this portion only. We are comparing for only this portion. So this portion of the graph will convert into this type of function. That function is cos graph, this is minus cos graph. That is why answer is given option A. Now are you clear about this? Yes? This is a good question. So this type of question is very much fundamental, and it is checking your knowledge about the equations. So remember now, if we have not written correctly, so it is right there. So if y is equal to a sine omega t minus kx, pressure function, pressure of delta p, this is minus delta p max, you can write. It is cos omega t minus kx. Similarly, the density function will be in the same manner, minus delta rho max, it is cos omega t minus kx. Clear? Yes, we should note this. Minus is there, which we should not ignore it. Okay, then let us move to the next question. Question number 6. For a sound wave traveling towards plus positive x direction in air, sinusoidal longitudinal displacement at a certain time is given as a function. Again, this is displacement versus x graph, y versus x graph is given. Sound wave is traveling in positive direction, and the graph is given like sinusoidal function. They have given these values are given. This is 10 to the power plus 1 and 10 to the power minus. It should be same now, amplitude should be same. Okay, this is given 10 to the power plus 1 meter. This is given 10 to the power minus 1 meter. I don't think this is correct. Huh? This cannot, because it should be plus and minus. Huh? This graph is not looking correct, I think. Maybe it is plus 10 and minus 10. Maybe it is like this. Maybe it is plus 10 meter and this is minus 10 meter. Okay. Sinusoidal graph is there. Now they are saying that the variation of change in pressure. Now which of the graph is pressure wave? Again the same type of question is there, but now this type of graph we have to find out pressure wave. Pressure wave you have to. Options again I will draw. And what about these points? They are saying that this is 0, this is 0.1, this is 0.2, like that it is. Okay, and in the pressure wave, the graph is given like this. Now I think you will be able to figure out what type of graph it will be. This is first graph. The values here are 2 pi into 10 to the power 2. Pressure is in Pascal. Okay, units are SI units, and this value is minus 2 pi into 10 to the power 2. And here the values, they are showing this value 0.1, this value 0.2. Second graph, these are pressure graph. Okay, pressure versus X graph. Second graph is here the values are also 0.1, 0.2. The positive value here is 5 pi into 10 to the power 2. Negative value is minus 5 pi into 10 to the power 2. Okay. Then similarly other two graphs are also there. How to minimize this? Okay. So you note this first graph. First you note this graph portion, which is displacement versus X graph. You first note this one, because I will draw the other CD option also. And all the units are SI units. Okay. Okay, so note this graph, YX graph, you can note it. So this graph is sinusoidal, and this plus 10 minus 10, and this 0.1, 0.2, like that it is going. Done? Then I will draw. Then you start solving this. I will draw the other option also. Option C. The upper value is 2 pi into 10 to the power 2, and the lower value is minus 2 pi into 10 to the power 2. Last graph is 5 pi 10 to the power 2 minus 5 pi 10 to the power 2. Okay, now you try. I think this you can easily do, just like previous graph. You have to figure out which graph, pressure graph, and it is minus cos graph. Remember, it is minus cos graph. So this you can definitely do it. And what about bulk modulus? They have given bulk modulus in the question. Okay, bulk modulus value they have given. Bulk modulus is 5 into 10 to the power 5. This they have given. Try this. Remember, we have to choose minus cos graph, so you can easily eliminate wrong option, right? Eliminate wrong option. So this is cos graph, eliminate that. We have to keep minus cos graph. So you can eliminate this cos graph, eliminate. These are minus cos graph. Only thing now you have to choose the values of the amplitude. So pressure amplitude and displacement amplitude, how are they related? You can refer to the previous solution what we have done here. So this pressure amplitude was what? Here we derived. This is the pressure amplitude. Remember this formula. BAK or BKA. Minus is because of cos is minus, but the value will be BKA. Remember, BKA will be the amplitude. So go to that question and check that. So you need to make sure the amplitude of pressure is BKA. Now you can do that. Option D, yes, you are right, correct. You got this. Okay, so B is already given, and amplitude Ka, from there we will calculate. So from this, what can we get? K means wavelength we can get. So from here, this lambda is 0.2. Lambda is 0.2. Once you got lambda, so K is 2 pi by lambda. That means 2 pi by 0.2. So that means it becomes 10 pi. Right, and amplitude here A is how much? Amplitude is 10 meter. Amplitude is 10 meter. So amplitude is 10. This is K and B is given. So what is BKA? What is BKA? BKA means B is 5 into 10 to the power 5. K is 10 pi into A is 10. So this becomes 5 pi into 10 to the power 7. Correct? 5, 6, 7. Right? Let us check that. 5 pi is correct. 10 to the power 7. Is it 10 to the power minus 1 or what? Is amplitude 10 to the power minus 1? Amplitudes are in meter only. Why they have 5 pi is coming? That's right. But this should also match 10 to the power 7. Why it is coming? Maybe the value is not given correctly, right? Okay, so leave it. But 5 pi is matching, so this will be considered correct. Clear? Understood this, right? Okay. Let us move next. So this type of graphical question is important to solve. Okay, now let us go to the next. Question number 7. Ratio of intensity between two coherent waves are. So there are two coherent waves, their intensities ratio I1 by I2 is given as 4 by 1. Difference in sound level is difference of sound levels decibel between maximum and minimum intensity when they interfere in species. They are asking difference of sound waves. So suppose for the first wave this is beta 1 and for the second wave it is beta 2. So this difference they are asking to calculate. Okay, they are asking to calculate the loudness in decibel, what it will be. Difference in sound wave in decibel between maximum. Okay, so this is related with maximum and this is related with minimum. This is related with minimum. This they are asking, and what are the options given? 10 log 2. Second option 20 log 3. 20 log 3. Third option 10 log 3. Fourth option 20 log 2. Try this. Note that question you have to understood properly. So questions are there. There are two sources are there. First source and second source. Their intensities ratios are given. Okay. At any point you take, there will be maxima minima is happening. So this question is related with superposition also. So maximum minimum means there is a superposition happening, and you have to think about maximum intensity and you have to think about minimum intensity. This is due to superposition, and corresponding to maximum intensity there is maximum loudness, and corresponding to minimum intensity there is minimum loudness. So you have to think like that. Then you can calculate like this. Okay, try that. So tell me the formula for beta. Tell me the formula for beta. Yes. Loudness formula we discussed today, right? 10 log base is 10 only. So no need to write here. Log base is 10 only. So let it be 10 log I by I naught. Correct? This is the form, right? Now when you have to write here beta max, so this intensity is also intensity max. Similarly, when you have to write this beta minimum, so this will become log I minimum by I naught. Now you subtract that. So you need to do subtraction of this. So beta max minus beta minimum. 10 you can take common. 10 I taken common. And you know log A minus log B is log A divided by B, right? You know that, right? Okay. So you divide this. So when you divide log, means log will remain, this factor will get divided. And when you divide this, I naught will get cancelled, it will be I max by I minimum. I max by I minimum. Correct? Now, what you need to do? Now you need to simply try to calculate this factor. What is I max by I minimum if I1 by I2 is given, and I think you know about this formula. Yes. You know I max by I minimum if I1 I2 is given. So what is that formula? I max by I minimum. I max by I minimum formula is A1 plus A2 by A1 minus A2 whole square. We have done questions on this. Okay. So A1, A2 you need to calculate. Do that, because this is intensity amplitude square, right? This is A1 square by A2 square. So take square root, so you will get A1 by A2. So A1 by A2 you got as 2 by 1 over. So 1 you can take 2, another you can take 1 and substitute here. Substitute this. So 2 plus 1 3 by 2 minus 1 1 square. That means it is 9. It is 9. 9 or 3 square we can write. Okay, let's write as 3 square, because here we are going to substitute that. So substitute this there. So this is going to be 10 log, this is coming as 3 square. So let us write this as 3 square. And log a square means power will come outside. So 2 will multiply with 10. So 20 log 3. Yes, this is the answer. 20 log 3, this will be the answer. 20 log 3. Yes, second answer. This is a good question. Now they have applied what concept? Superposition concept. They have applied concept of loudness also. So sometimes questions will combine more than one concept. Okay, then let us go next. Question number 8. A subsonic fighter jet flies overhead at an altitude of subsonic fighter jet. The sound intensity on the ground as the jet passes over. So there is a jet. Okay, some diagram, rough diagram I am drawing. Okay, so this is a jet, fighter jet, subsonic fighter jet. Subsonic fighter jet means it's like a fighter jet which is going with a speed almost near to sound. Okay, so the question is that it is at an altitude. So from the ground, this is ground, from the ground it is at a height of 100 meter, and there is a person which is standing here, let us say on the ground, and it is just going to pass over his head. Sound intensity just passes over it. So when he is here, and this is passing over it, he is hearing an intensity in decibel of 160 decibel he is hearing. Okay, then the question is, at what altitude should the fighter jet fly so that the ground noise is not greater than? They are saying that the ground noise should not be greater. What height? Let us say now it should fly more height, at let us say, so that this decibel should not be more than that. It should be less than, should not be greater than 120. It should be less than or equal to 120 decibel. Why? Because you know this fighter jet will produce lot of noise if they are going very close to the earth. Then we will become disturbed so much because their noise is so much. Okay, so we want that its noise should be less than 120 or maximum 120 decibels. So what is this height? That is the question. Try this. So how to think about it? See, you can consider decibel in terms of intensity, and you know that intensity is and distance relationship. What is intensity and distance relation? Yes, R square, right? We see that suppose this is a source and this is a point where you want to see intensity. This distance is R, so intensity is proportional to 1 by R square. This concept we can use, okay? And also note that beta formula, let us write intensity I formula in terms of beta. So I is uh, I formula is what? 10 to the power it is, right? What formula I is? Because beta is 10. Beta formula is 10 into log base 10 I by I naught. This formula was I naught into 10 to the power beta by 10. Correct? This formula. Remember, so this formula we can use and so we can write intensity here is proportional to I naught is anyway constant is 10 to the power beta by 10. That's what you have to think, and I is proportional to 1 by r square. So you can write 1 by r square is proportional to 10 to the power beta by 10. This concept we are going to use here to solve question. Okay. So first case you take beta as 160 and distance is 100. So let's write first equation. So 1 by 100 square, 1 by 100 square is proportional to 10 to the power beta is 160. So 160 by 10 becomes 16. This is first equation. Second equation you write as h. So 1 by h square is proportional to 10 to the power 120. Beta is 120, so beta by 10 becomes 12. This is second equation. Now you need to solve h. So you can divide first divided by second. First equation divide second, you do, what do you get? So h will come in the numerator, so it will become h by 100 whole square. H by 100 whole square is equal to 10 to the power 16 by 10 to the power 12. So 10 to the power 4 will be there because 16 minus 12, right? Now you take square root and solve. Square root and solve. So h by 100 square root of this. So 10 to the power 4 square, it means 10 square will come. So h will become how much? H will become 100 into 100, 10,000. Correct? 10,000 meters. This should be the answer. 10,000 meter will be 10 kilometer. 10 kilometers. Okay. So the options are given as above 10 kilometer above ground, 1 kilometer above ground, 5 kilometer above ground, 8 kilometer above ground. So 10 kilometer above ground, because this is the minimum level we have taken. It should be more than that. Above ground. Yes, this is the correct answer. Clear? Yes. Okay, then next, let us go to the next. Question number 9. Okay, tuning fork of frequency 512 hertz is vibrated with a sonometer wire and 6 beats per second are heard. So there is a tuning fork. Tuning fork. What is the frequency? Its frequency is 512 hertz. And there is a wire. Sonometer wire you can consider like wires are fixed both sides, and this wire is also vibrating. Okay, and you do not know what is the frequency because it can vibrate with different modes, right? Fundamental, second harmonic, third harmonic, it can vibrate with any frequency. You do not know what frequency it is vibrating, but they are saying that there is a beat happening. Beat happening means beat is the difference of frequency. Let us say that this is the frequency of this wire and this is the tuning fork frequency, which is of course constant. Tuning fork frequency is constant because tuning fork is coming with a constant frequency. Okay, Now the question is that the sound intensity, sorry, the beat, there is a beat of, right now there is a beat frequency of 6 hertz, 6 beats per second. Okay, now the question is the beat frequency reduces if the tension in the string is slightly decreased. Now they are saying that there is some tension in this string, this tension is decreased, tension is decreased. If tension is decreased, so beat frequency reduces, beat frequency slightly decreases, slightly reduces. Okay, they are saying that it slightly reduces. Beat frequency, the original frequency of vibration of a string is, what is the original frequency of the wire? Okay, when tension was T, now tension has become smaller, right? So this tension is decreased, so now bit frequency is different. Previously bit frequency was 6 hertz. How will you approach this question? Because see, you know that, okay, options also I will give so that you can choose that. A, B, C, D. What are the options? 506, 512, 506, 512, 518, 524, 518 and 524. How to approach this question? You know the formula, there is no doubt, you know the formula, beat frequency, the difference of frequency. So 6 hertz is the difference of frequency. So is it 512 minus, or is it this frequency of wire minus 512? So you remember that class I told it can be either 512 plus 6 or 512 minus 6. Remember that? So which can be possible answer without doing anything? Guess out. 512 plus 6 means 518 can be possibility. 512 minus 6 means 506 is a possibility. That means you remove this. Two options are gone anyway. Now you have to choose either A or C. Okay, so now how to do that? So you need to think about frequency of wire. We know that frequency of the wire is, if you take fundamental or anything you take, it doesn't matter, it is proportional to V by 2L. If you take fundamental, then it is V by 2L. Generally you can take fundamental, okay, V by. So in any case it is proportional to speed. So this is proportional to speed, we know that. And speed is proportional to root under tension, right? Root under tension by mu in string wave. So wire frequency depends on root of tension. And if tension is decreased, because tension is reduced, so this also reduces. Okay, so when the wire frequency reduces, beat also reduces. Now you have to think about what kind of formula should I write. Suppose if I write the formula for beat formula, if I write as tuning fork minus frequency of wire, either it can be this or it can be wire minus tuning fork, right? Either it can be this or this. So now think about it, try to fit the information here. So if you decrease the wire frequency, and this beat should also decrease, that is what is given in the question. So if you decrease the wire frequency, in this case first equation, what will happen to the beat? Will it decrease or increase? Yes. See, note that you are subtracting this term. Suppose you are subtracting this term, and the term which you are subtracting, it becoming smaller, then what will happen to this bit? Will it increase or decrease? Okay, take with example. Suppose there is 10. From 10, I am subtracting 8. Resultant is 2. Suppose from 10, I am subtracting 5. Now, what is the answer? 5. So, it is increasing or decreasing? Yes, you are correct. So if you decrease, if, this is what we have to understand. If you are decreasing this term because you are subtracting this and you are going to subtract smaller and smaller, then this will become larger and larger. So decreasing this increases this. But here if you take second equation also I will write this. If you use second equation, here decreasing of this, you are subtracting from this term. So when you are subtracting from original term and this original term itself decreases, so this will decrease then. Yes, right? Are you getting this? This you need to understand. This is a very basic maths it is. So here you are subtracting here. So when you are decreasing the quantity which you want to subtract, that is become, that means you are subtracting smaller and smaller quantities. So this will be larger and larger. And here the quantity from which you are subtracting, that quantity from which you are subtracting, that quantity itself is becoming small. So if this is quantity is becoming small, so this will become also small and small. So if you can understand this, then tell me which formula, which one should we use? Should we use first or second equation? Yes, because in the question they have given that if wire frequency decreases, this also decreases. So we must use this one. That game is over now. Then we choose this one. So we want to wire frequency. Wire frequency will be equal to beat frequency plus tuning fork frequencies. So we use this plus tuning fork. So that means you have to add the beat. So 512 is there, plus add 6, plus 6 means 500. So this is the correct answer. Clear? Yes? Like that you can solve questions from this. Beat frequency questions will come, and now I will tell you one important model question that is going to come here is there is two term called waxing and filing. Waxing and filing. So waxing means it is also called loading. Filing, or it is also called sharpening. The tuning fork, although tuning fork is a constant frequency, but by doing some extra, modification, we can change the tuning fork frequency also. Let us say tuning fork, you put some load, some wax you put, right? So in that case, tuning fork frequency will change. Similarly, if you tuning fork you sharpen by knife or you remove some masses, then also frequency will change. Now, how does mass affect that? So generally what happens if you increase the mass, so here frequency will decrease. Frequency decreases. Okay, and sometimes this when you are sharpening or filing, then frequency will increase. Okay, so note this idea, filing or sharpening will increase frequency. Why? Because for a wire also you can do, when wire mass changes, so mass means mass per unit length, density will be decreasing. So as density decreases, this will increase, because the frequency is proportional to, you can say, root of density. For sound waves it is like that. So when you reduce mass or you reduce density, so it will increase. Same thing is here, right? Frequency is proportional to 1 by root of this. So if you are increasing this, then this is decreasing. So this case you have to understand. Sometimes question they say that you have loaded, now beat frequency have increased or beat frequency has decreased. So you have to decide what happens when you increase one of them and the beat frequency increases, like the previous thing we have seen that. So here suppose if I write beat frequency as f1 minus f2 is beat, and let us say that f1 is not changing and f2 is changing. Let us consider that f2 is changing, f2 you are changing, okay. F2 you change, beat will change. So how f2 change will affect the beat? Suppose if you, let us say if you increase this, if you increase f2, what will happen? If you increase f2, this will decrease, note that this will decrease. And if you decrease f2, if you decrease f2, then beat will increase, right? Are you getting this? This is how you have to understand. So increasing of f2 decreases beat and decreasing of f2 increases beat. Then in that condition you can apply this formula. But suppose f1 is changing, then change of f1 is different, okay, it will affect differently. Suppose you consider f1 minus f2 is equal to beat. Now let us say you are changing this, you are changing f1 now. Then what happens? Let us say you are increasing this, you increase this. If you are increasing f1, then definitely this will also increase. This will also increase. And if you decrease f1, then this will also decrease. Clear? So we should note about this, changes that can happen. We can apply these changes in the question. Are you clear about this? Okay, then let us move to the next few more questions so that you will have some practice. Then I will send some worksheet which you can. So this is a good book. This book is SBT C. Bhushan Tiwari. This is a very good book for conceptual. Right now, you should not think that I have to do NEET or JEE. You need to think of building the concept. And for building the concept, whichever book is good, you should take that. Okay. And this is a very good book. Concept is very good and problems are also very good. And at the end of the book, there are 3 worksheets are given. So right now I'm solving some question from worksheet 1. So I will take worksheet 1, 2, 3. I will send you. You practice, take 2-3 days practice. I will also set the test papers. Okay, I will keep one test on this chapter, and then you write, after practicing you write that test paper. Then you will feel the difference, right? So when you practice lot of questions, you will get full confidence that you know this topic. And then when you write, and also note important thing, while you are practicing the question, initially you may take more time because you are simply practicing and you are thinking more, so it may take some time, you may make mistake. But after some time, after solving some 100 questions, then you should pick up speed, because you will get the idea of what type of questions are there. You have got the experience. Once you got the experience, then by seeing any question, you know what calculation you have to do. After that, you have to just do the calculation, right? So speed will come, but not immediately. After, maybe after 80, 90, 100 question, when you solve on a topic, you will get that speed, right? But you have to be very active in solving problem, then only it will happen. Okay, right, let us go to the next question. Number 10. Question number 10. S1 and S2 are two coherent sources of sound having no phase difference. So there are two sources of sound. This is S1 and this sources of sound S2. There is no phase difference. No phase difference. Okay. Velocity of sound, and they are saying that the separation between these two is given as 3 meters. And this is one line there. So velocity of sound velocity is 330 meter per second, they are given. Okay. No minima is observed on the line passing through S2 and perpendicular to the line S1. Fine tuning estimate, possible frequency of. They are saying that if you move in this line, there is no minima. No minima is observed. No minima is observed. That means suppose there is a person who is moving in this line. Okay, this line means it is moving. This line is of course perpendicular to that line. Okay, so S1 S2, if you join a line, this line is perpendicular to that. This is like x-axis and this is like y-axis, you can take that. Okay, this is like y-axis, you can take that. This is x-axis. So this person is moving along x-axis, he does not find any minimum intensity. So the question is possible frequency of the sources is possible frequency of the sources, possible frequency of the sources is, sources means either S1 or S2, possible frequencies are they are asking, but answer is only one option given, that means any one of the frequency they are saying. So possible frequency is 50 hertz, 60 hertz, 70 hertz, 80 hertz. Try this. And note that in the question they have also said that the two sources are coherent. Two sources S1 and S2 are coherent sources. Coherent sources. So coherent sources itself means that they have same frequency. They have same frequencies. So they don't have two different frequencies. They have same frequency. So definitely this question is not a question of beat, because beats have different frequencies. Correct? Beats have different frequencies, but this question is not a beat question because the person is walking over that, so he is not standing at one point, right? Generally in the question of beat, you will stand at one point and then you are hearing the maximum minima. That is superposition with respect to time. But here they are coherent sources. Coherent sources means beat will not happen, because beat happens in incoherent sources where they have different frequencies. Okay. Okay, so but they are saying there is no minima, means what? Minima is not happening. So what you can approach is, you can consider that minima is happening. Assume that, let us say that there is a minima happening, and find the condition for minima and then negate that condition. Negate that condition means, suppose you got the condition of frequency as 20 hertz or 30 hertz or 40 hertz, like that, minima. So those frequencies should not be there in the option. Understood? Right? You need to think like that. So first try this. Okay. Okay, assume that there is a minima happens, and let us take that this person is some distance from here. Some distance, let us say this distance is x. This distance is x. This is the second source, right? And from the first source, this distance will be how much? Because this is hypotenuse, so this will be root under 3 square plus x square. Correct? Yes. This will be x and this will be root under 3 square plus. So path difference we have to calculate. What is path difference? Delta x. Delta x path difference will be root under 3 square plus x square minus x. Path difference means distance of the path. Okay, and path difference. Okay, what is the condition for path difference for minima? What is the condition? Path difference condition. You remember? For maximum path difference condition, for minimum path difference condition. What is that? But it is not maximum. For minima, I am asking. For minima, what is the condition? N plus half or n minus half you can take. So let us take n minus half lambda, because when you take n minus half, n will start from 1. So n minus half lambda you can take. This is the condition for minima. So you are applying the condition for minima here. So this become root under 3 square plus x square minus x. Okay. And note that n is a integer starting with 1, because negative it should not be. Okay. So n can start with 1, 2, 3, 4 like that. Okay. Now you try to solve this. We need to solve this. So try to solve this now. So what? How do solve? I will take x that side. So n minus half lambda plus x will become root under 3 square plus x square. Now let us square both sides. If I do squaring both sides, then this will become 3 square means 9 plus x square. Root will get removed. This side square will come. So a plus b square, let us apply. So a square means this square plus x square plus 2ab, right? 2ab, so 2n minus half lambda into x, correct? So we have square both sides, so square plus b square plus 2ab. Now what happens is we can cancel out x square terms. X square term is cancelled. Then what are the possible values of lambda we can calculate from here? Try to find out the possible values of lambda, because if you know lambda speed, you know frequency, we can calculate. So from here, n minus half square lambda square plus 2 times n minus half lambda x is equal to 9. Correct. So what will be then x? X value we do not know, right? But n is 1, 2, 3, 4 can happen from here. What can we do? Can we take common something here? Suppose if I take n minus half lambda common, so this will become same n minus half into lambda, and this will become 2x is equal to 9. So from here we can say that n minus half lambda plus 2x is equal to 9 divided by n minus half lambda. What should we take as x here? What do you think x we can take from here? X we can try to calculate also from here. Sorry, X we can try to calculate from here. So what will be 2x from here? N by n minus half lambda minus n minus half lambda. So x will become 1 by 2, 9 divided by n minus half lambda minus n minus half lambda. Oh, what to do? What do you think we should do then? Because x terms are still existing here, correct? X can be, okay, we have seen this source is that side, so x can be positive. So let us apply the condition of positive value. So x should be positive, x cannot be negative, right? X cannot be negative. X can be 0, but x cannot be negative. So if I say that x is negative, then it may be not possible then. When is x negative? When this is smaller and this is larger, correct? This is smaller and this is larger. Can we apply that condition? Check. So that means n minus half lambda, this term becomes smaller than this term. When it is possible, that means lambda should be greater than 9 by lambda square will come. Lambda square will come as n minus, so lambda square will come as n minus half square. So from here we can say lambda should be greater than 3 divided by n minus half, correct? Lambda should be greater than this, then it will not exist. So what are the possible values of lambda now? You can think about it, right? Let us write now in terms of frequency. So lambda is equal to speed by frequency. Let us write this now, correct? And speed they have given in the question. How much is the speed? 330. So let us apply this condition. So speed is 330 by frequency greater than 3 by n minus half. So frequency will become greater than what? Now frequency goes that side. So frequency will become lesser than what? This becomes how much? 110 into n minus half. Now apply the conditions and choose. What are the options given? I will go to the option 110 n minus half. This is the, what is the answer? Frequency should be greater than 110 n minus half. Now choose some values of n and check which is the possible values. Suppose if I choose n as 1, so it will become half. Half means how much? 55, correct? 55. So greater than 55 are so many things. A, B, C, sorry, B, C, D, only this is coming less than, right? Sorry, this is less than it should be, less than, right? It should not greater than, less than it is. Are you getting this? Less than. So frequency must be less than this, and if you put n is equal to 1 minus half, that means frequency must be less than 55. And the only answer which is less than is 50, correct? Okay. So this is about maths. If you don't know these maths, then we cannot do. So some questions are there which is tricky. Maybe there may be some other approach also can be done faster. But logically, when you go like this, we can think in this manner. This is one of the method to think about the how to deal with the maths here. But maybe you can think of some other approach and try. Okay, so we have done some question, and I hope you got some ideas about this chapter. But this chapter is a heavy weightage, so you need more practice. I will be sending some worksheet today, and you first try to practice those worksheets. 3 worksheets are there. Some 10 question I think we have done it. Okay, remaining question you try to do. I will send the keys also, answer keys. Okay, fine, then we will, then you can write the test after. Okay, then thank you for your attention. Bye bye. Yeah.